We will continue the presentation of CSEC Multiple Choice Practice Paper 5 with Part B. These 15 problems will take us from number 16 to number 30. A man bought a calf for $200 and sold it for $250. What was his gain as a percentage of the cost price? And we are highlighting percentage of the cost price because it is important to note that the percentage that we need to find must be with respect to the cost price. The problem requires the gain as a percentage of the cost price. Probably the simplest way to solve this problem is to write the selling price as a percentage of the cost price. Probably the simplest way, but not necessarily. So there we have it. Writing the selling price over the cost price, multiplying by 100 to find the appropriate percentage. Reduce the fraction by a common factor of 100. This may be done by striking off 2 zeros from both numerator and denominator, as we usually do in primary school, reducing by a common factor of 100. We have 250 to be divided by 2, and after making such a calculation, the result is 125%. Therefore, the selling price is 125% of the cost price. The original, which is the cost price, is always considered to be 100%. The original is always 100%. Therefore, we need to determine the gain. How do we do that? We now need to determine the gain. The original is always 100%. The percentage that we have is 25%. This means that another 25% was added to it. 125 minus 100, and the result is 25%. The correct answer is option D. Generally, profit or loss is given as a percentage of the cost price unless otherwise stated. All the time that you are making your calculation, if there is no statement, I guess right here we did not have to apply our general knowledge because we have what is the gain as a percentage of the cost price. But unless otherwise stated, the gain or loss is always as a percentage of the cost price, unless otherwise stated. Here we have the very same problem, and we are about to take another approach in solving it. In solving the problem, most candidates would subtract the selling price from the cost price. There we have the selling price of $250. From that we are subtracting the cost price of $200, and the result is $50. The result is the gain or profit. It is then written as a percentage of the cost price. So here we have the gain divided by the cost price of $200, and we are writing that as a percentage by multiplying by 100. We will now reduce the fraction by a common factor of 100. This may be done by striking off 2 zeros from both numerator and denominator, as usual. Then all we have left is 50 divided by 2, and that results in 25%, confirming that the first attempt on the problem is actually correct. Mary invests $200 for 3 years at 5% per annum. John invested $300 at the same rate. If they both received the same amount of money in interest, for how many years did John invest his money? By using common sense, we may determine that John invested his money for 2 years. The correct answer is option B. Take a look at what we have there. Consider the figures in Mary's investment. We see 2, 3, and 5. We're not really considering that 5 is a percentage, a number to be divided by 100, and that we have 200. We are just taking a look that we have $200 here. We are just taking a look at the significant digits. We have 235 in Mary's investment. What about John's investment? Bearing in mind that the investments had the same rate, the figures in John's investment were 3 and 5. So the rate is the same. So we have this 5 that will also be a part of John's investment. And considering this significant digit here, we have a 3. So in John's investment, we have a 3 and a 5. And in Mary's, we have 2, 3, 5. If they are equal, then what? Only the 2 is missing from John's investment. Therefore, we know that the answer is actually 2 years. These numbers are identical to those in Mary's investment, with the exception of the one that is missing. If the interests are the same, the missing number from John's investment has to be 2, since the end results have to be the same. So if we have 2, 3, 5 in Mary's, we have 3 and 5 in John's, then the other number is automatically 2, since both of them are equal. With x being the unknown time in John's investment, let us write an expression in which the interests on both investments are equated. So we are equating the expression that calculates the interest on Mary's investment with the expression that calculates the interest on John's investment, because both of them are equal. There is the equation that we had from the previous slide. Multiplying the entire equation by 100 will eliminate the denominators. That is always a very good first step when we are solving equations. Eliminate the denominators by multiplying by the common denominator. Not difficult on this occasion because the denominators are the same. Those denominators are gone. Dividing an equation through by a particular common factor does not change the equation. We always do that, divide an equation through by a particular common factor, and we are comfortable doing that because we know that dividing or multiplying an equation through by a common factor does not change the equation. Now let us divide through by 100. This may be achieved in brief by striking off zeros from both sides. Should say the number of zeros, 2 zeros each from the different sides of the equation. 5 is also common on both sides. Let us divide through by 5 also. Those are gone. If we are not careful, the 3's on both sides will go by unnoticed. Let us divide through the equation by 3 also. So we are dividing the equation through by 3 also, and what do we know? The only remaining factors are the 2 on the left hand side and the x on the right hand side. X is equal to 2. Although it may not be so important in determining the correctness of the answer, the numbers that cancel each other may be best crossed in the same way. This will help someone else to follow the steps that you used in solving the problem. Of course, it does not matter in this multiple choice problem, but may be very important if you are solving a structured problem or an essay type problem. Showing that 3 cancels with 3 by using vertical strokes, also that 5 cancels with 5, and show which of the hundreds cancel. Maybe not so important in this particular case because we have so many hundreds cancelling, but in the event that we have several different numbers cancelling, or for saying this a better way, reducing by other factors, it may be important in making yourself clear to the person who is marking your paper if you cross the ones that you are taking together in the same way. During a sale, a shop allows 20% discount off the marked price of clothing. What will a customer pay for a dress with a marked price of $30? We will take a few quick attempts at this problem. The first one will be the traditional way. Find 20% of 30, then subtract the result from 30. So we have 20 over 100, that is 20%, and that is being multiplied by 30. See what that gives. 600 over 100, that is equal to $6. What do we do with that $6? We subtract that from the original price of $30. The result is $24. The correct answer is option C. Alternatively, what do we do? Another way is by considering that the original is 100%, from which we will subtract 20%. This results in 80%. 80 over 100, that is what 80% is, and that is equal to 0.8. Reducing by 20% is the same as multiplying the original by 0.8. So 30 multiplied by 0.8, and what do we do as usual? Multiply the numbers as if there is no decimal place. That is what we always do. Then the product has one place of decimal, so let us put that one place of decimal in the answer. Traditionally, when we multiply numbers that have decimal places, we just multiply the numbers as if there is no decimal place. Then what do we do? Count the number of decimal places in the numbers that we are multiplying. Well, we have only one right here, and then that number of decimal places, well, we only have one place in this case, so we have one place of decimal in the answer also. We may also find 80% of 30 without using decimal. 80 over 100 multiplied by 30 over 1. So there we have 2,400 divided by 100, and that is $24. The 80% is what we received by subtracting 20% from the percentage of the original, and of course the percentage of the original is 100%. Subtracting 20, as it says, allows 20% discount, so we subtract 20% from 100%, we got 80%. Therefore, the amount paid for the dress will be 80% of the original, and that will turn out to be $24. The table shows the rate charged by an insurance company. How much will a person pay for his insurance if his house is valued at $50,000 and the contents at $10,000? Of course, we will need to multiply the amount or the value of the house by the rate for the house, and we need to multiply the contents by the rate of the contents. But let us not be too jumpy. At first glance, the figures might give the impression that rates are 50%, which is of course 0.5. So if we just take a look at this, 50, 100. So we say, okay, 50, 100, the rate is 0.5. Or we may say 25, 100, the rate is 0.25. This is because the figures are out of 100, as we can see right here. We see 50, we see out of 100. We are hasty to say one is 0.5 and the other one is 0.25. But if we take another 5 seconds to look, what do we notice? It is for us to understand that the rate is not 50 cents per 100 cents, but 50 cents per $100. Since 100 cents make a dollar, we may convert the dollars into cents by multiplying by 100. And it is advisable, and sometimes the CSEC will set a problem in which the units are different, cents to dollars. Sometimes candidates will be hasty and they are off on a speed, making use of 50 cents per 100 cents, and they make a meal of the entire problem. But we are keen and we notice that it is $100. We need to convert the $100 to cents, and that may be done by multiplying the $100 by 100. That will convert it to cents, and the rates are now 50 per 100 times 100 and 25 per 100 times 100. Turns out to be 50 per 10,000 and 25 per 10,000. In the rate, we will not divide by 100 but by 10,000. This will result in a reduction by 4 places of decimal. So there we have it. The rate is actually 50 over 10,000 and 25 over 10,000. The values may now be multiplied by their appropriate rates and the results added in order that the amount paid for insurance may be determined. So let us take the amount, that one, and multiply by its rate. Then we take this amount and multiply by its rate, which is of course 25 over 10,000. And that may be a bit cumbersome, but we see that simplification is not going to be very difficult. We may reduce both fractions by a common factor of 10,000. 10,000 there, 10,000 there. 250 plus 25 is equal to $275. Here we have 5. That is the only thing that is left in this fraction. 5 multiplied by 50, that is 250. And we have 1 multiplied by 25, and that is 25. Putting both of them together, we have $275. The correct answer is option B. How much does a customer pay for an article marked at $50 if a sales tax of 6% is charged? By looking beyond the surface of the problem, we may be delighted that the amount of money used is $50. A percentage is out of 100. This is a simple relationship. We have 50 is a half of 100. The amount of money must be half of the percentage. The percentage is 6. The amount of money is 3. We need to increase $50 by 3. 50 plus 3 is 53. The correct answer is option C. If we can see how simple this can be done, probably we could take a look at it here. We have 50 and we have 6. If we use 100, 50 is a half of 100. That means the amount of money must be a half of this percentage. It may not follow as simply as I am looking at it. If it does not, then we have other approaches that we may use in solving the problem. But it is not difficult to see, since we are talking about percentage, 50 is a half of 100, therefore whatever we are using for the amount of 6%, it must be a half of 6, which is 3. But if that is not so clear-cut, let us move on. If this is too harsh, we may go ahead and find 6% of 50 and add the result to 50. So 6 over 100, that is what 6% is, multiplied by 50. What happens? 6 multiplied by 50 is 300. 300 divided by 100 is equal to 3. $3. Turns out to be $3. Then we add $3 to $50 and we have $53. The correct answer is option C, as we have calculated before. So we are now confirming that we were correct. I'm sure that we are not confirming ourselves in error. So we are confirming that we are correct. Another way is by considering that the original is 100%, to which we will add 6%. This results in 106%, which is equal to 106 divided by 100, turns out to be 1.06. Increasing by 6% is the same as multiplying the original by 1.06. So 50 multiplied by 1.06, that is what we need to do. Multiply the numbers as if there is no decimal place. That is what we always do. We end up with 5,300, and as usual the problem has two places of decimal, so will the answer. From primary school we learn to multiply numbers that have decimal places as if they do not have any decimal place at all. In the end, we count the number of decimal places in the part that we are multiplying, and we ensure that the answer has the same number of decimal places. We may also find 106% of 50 without using decimals, so write 106% as 106 over 100. That we multiply by 50. The numerator turns out to be 5,300, that we divide by 100, and we have $53, confirming that we were correct. Surely we are not confirming ourselves in any error. The 106% is what we received by adding 6% to the percentage of the original, and the percentage of the original is 100%. A company employs 12 gardeners at $26 per day and 8 clerks at $17 per day. What is the mean daily wage in dollars of the 20 employees? The mean daily wage may be found by dividing the total daily wage by the number of employees. That's how we find the mean. Total of all the entries divided by the total number of entries. The amount paid to the gardener may be found by multiplying the wage of each of them by the number of them. So how much do we pay all of those 12 gardeners? We multiply the amount paid to each one by the number of them. To that we will add the product of the number of clerks and the daily wage of each. How much is paid to the clerks in total? We will take the amount paid to each clerk and multiply that by the number of them. The total wage daily will be the total of those paid to the gardeners plus the total of those paid to the clerks. So let us add that. Let us now calculate the products. We have 12 multiplied by 26 is 312, and 8 multiplied by 17 is 136. The sum is $448. This represents the total wages paid to the employees each day. Mean is equal to $448 divided by 20. The total paid to all of them divided by the number of them. Mean is equal to $22.40. The correct answer is option C. Dividing by 20 is a simple process. For some candidates, it is automatic. However, we may make use of the simple principle. Division by a product is the same as successive division by each factor. Dividing by 20 is the same as dividing by 2, then by 10. So we will take 448, divide that by 20. 20 is 10 multiplied by 2, so we take 2 first. 448 divided by 2 is 224. Very easy on this occasion because each digit is a multiple of 2. So we know 2 into 4, 2, 2 into 4, 2, and 2 into 8, 4. That's very simple. After dividing by 2, we will then divide 224 by 10, which is equal to 22.4. And that is as simple as reducing by 1 place of decimal. A man pays 60 cents for every 200 meter cube of gas used, plus a fixed charge of $13.75. How much does he pay when he uses 55,000 meter cube of gas? We need to pay special attention to the fact that 60 cents is for every 200 meter cubed. Our first duty is to determine how many 200 meters cubed are in 55,000 meters cubed. This may be done by dividing 55,000 by 200. Reduce the fraction by a common factor of 100 in the traditional way, striking off 2 zeros from the numerator, striking off 2 zeros from the denominator. 550 divided by 2 is 275. We could have done the calculation mentally by separating the 550 into 550. Then say 500 divided by 2 is 250, and 50 divided by 2 is 25. So we add 25 and 250 together, and the result is 275. Do not forget that the amount is not in dollars. 60 cents may be converted to dollars by dividing by 100. Right, so we need to be aware immediately that the amount that is stated, 60, is not dollars but cents, and we need to convert because all of our options are in dollars, so we need to convert those 60 cents to dollars. So 60 divided by 100 is equal to $0.60. Converting to dollars so that our calculation can be smooth and crisp. The rate may now be multiplied by 275. So our rate of 0.6 multiplied by 275, and we have $165 That is represented by option B. There's your answer, option B, for all of you who have forgotten the fixed charge. For the rest of us, add the fixed charge to the result. That is what we are going to do. Add the fixed charge to the amount that we have there. And the result turns out to be $178.75. And we need to change that to option D. The correct answer is option D. Perfect. Here is a beautiful algebraic problem. Some of you will say that it is because it is very simple. When my students return from the multiple choice examination each year and they say that it is easy, I start to worry, because I know multiple choice problems that they are usually more than what meets the eyes. The problem just requires us to expand the brackets, applying the distributive law, that's what we mean, while not turning a blind eye on the basic applications of the rules that govern the manipulation of positive and negative numbers. Let us expand the brackets. Negative 2 multiplied by x is equal to negative 2x. Although there is no positive sign preceding the x, as a matter of fact, there is no sign at all. X is positive. So, when we do not see a sign preceding any number or term, we know that that term is positive. So, negative multiplied by positive results in a negative. Negative 2x. What do we know next? Negative 2 multiplied by negative 4. Negative multiplied by negative results in a positive. Very nice. The correct answer is option A, as we can see. I was a bit critical of the problem until I reflected on the common mistakes that students make. A. They sometimes apply a negative sign to a number preceding it. Therefore, they would consider the negative sign that is inside of the brackets to be pertaining to the x. So they say that x is negative because we have this sign here. As a matter of fact, even this week, some students made that same mistake. But it is not pertaining to the x. If we had a sign in front of the x or preceding the x, then we know that that sign is related to the x. However, on this occasion, we do not have a sign preceding the x. The x is considered to be positive. Although none of the distractors captured that, the problem is still not as simple as it appears. So none of the distractors capture the fact that some students may have made the mistake of having considered that the x is negative. So we do not have any of the distractors capturing that possible error by the candidates. B. Some may have a lapse in concentration or may not be aware that a negative multiplied by a negative is equal to a positive, which is what we have here. Negative multiplied by negative is positive. Some candidates may not make that calculation correctly, probably by a lapse of concentration, or they are a little bit off in applying the distributive law. And C, some may forget to distribute the negative 2 to the second term in the brackets. I remember one CSEC report making mention of such mistakes that we have candidates making. That is, the negative 2 is not distributed to the negative 4. Therefore, the students will just negative 2 multiplied by x, negative 2x. Then negative 2 is not used again. We just say minus 4 and we put minus 4 here. The distractor is there for it, and I think that is a beautiful distractor that we have right there. So the common mistake of not distributing the negative 2, the one that precedes the bracket, to the other term in the bracket is a common mistake that students make. Here we have a problem that requires the manipulation of binary operations. Let us see what this one has in store for us. This problem involves a binary operation. This is just an instruction given algebraically. Pay special attention to the details and we will have no difficulty. First, write the left-hand sides of the initial algebraic expression and the problem as we are required to solve. The right-hand sides are written as templates. That is the left-hand side of the statement of the problem, and we have the left-hand side of our proposed solution. As the a is first and is placed in the denominator of the fraction, the 7 is first and is also placed in the denominator of the fraction. So a will go in the denominator, so will its associate be placed in the denominator. As the b is second and is placed in the numerator of the fraction, the 28 is second and is also placed in the numerator of the fraction. Therefore, the b and its counterpart are placed in the numerator. On the left-hand side, in the solution of the problem, we have 28 divided by 7 is equal to 4. Therefore, we have 4 minus 1, which is equal to 3. The correct answer is option C. Generally, the problem that candidates have in arriving at the correct answer in such a problem is that they always place the first letter first. In this particular case, they may place A in the numerator because it is the first, neglecting the fact that the first one, which is A, belongs to the denominator. So some students, in solving a problem like this, they say A, B. They say because A is first, they put A up there, then they put B down there. Well, that is what is required of the statement or the expression of the binary operation, that we have A asterisk B means that B is the numerator and A is the denominator. But in solving the problem, the student may say that since this one is first, put the 7 there and then put the 28 here. As a matter of fact, 28 into 7 is what will give us a quarter right here. Then we will take away 1 and that will give us a negative 3/4. The examiners are fully aware that candidates will make this common mistake of just putting the first one first, when in fact, according to the code or rule given by the binary operation, the first one should be placed in the denominator. All that is required in solving this problem is for us to expand the brackets and combine the like terms. We will begin by expanding the brackets. So we have 5 times 2x, that will give 10x. Then 5 multiplied by negative y and negative 5y. We are finished with that first part of the expression. Negative 2 multiplied by 3y and negative 6y. And finally, negative multiplied by negative is positive, a positive 10y. Let us combine the like terms, if any. So we will identify the like terms and combine them. First of all, we have a 10x and another positive 10x. We have 10x plus 10x is equal to 20x. That goes there. There we have another pair of like terms. They have the same sign. They are negative. Whenever we add numbers that have the same sign, we add the values and the answer will take the same sign as the numbers that we have added. Rule 2 of adding positive and negative numbers in Richard James Mathematics Resources. So we have a negative 11y. Adding the values and applying the common sign to the answer. The correct answer is option D. Here's another one. All that is required in solving this problem is for us to expand the brackets and combine the like terms. We will begin by expanding the brackets. 3a multiplied by a, that will give us a times a is a squared, 3a squared. 3a times 2b, 3, 2, 6, a times b is ab, 6ab. Negative b now multiplied by 2a is a negative 2ab, and we will finish up with negative b multiplied by a negative 3b, and we have a positive. Negative multiplied by negative is positive. We have a positive 3b squared. Let us combine the like terms, if any. Can we identify any like terms? There we have them. Plus 6ab minus 2ab. 6ab minus 2ab is equal to 4ab. When adding algebraic expression or subtracting, as we have right here, we combine the coefficients. The 6 and the negative 2 will give us a positive 4. The term is not affected in any way. So the term, which is AB, is applied to the result of combining those coefficients, applied as it is. So we have 4AB. No more like terms. The unique terms will be included as they are. There we have those unique terms included just as they are. The correct answer is option B. 3a squared plus 4ab plus 3b squared. For those candidates who are on top of their algebra, they may think that the problem is very simple. However, I see that some candidates will be found wanting if they do not apply the distributive law properly, especially the consideration of the results of multiplying positive and negative numbers. Some candidates will laugh when they see a problem like this. Those who remember how we used to have some of the best times of our lives adding fractions, especially those that have the same denominator. 4 over 5x plus 2 over 5x. What is that equal to? When adding fractions that have the same denominator, all we need to do is add the numerators and place the sum over the denominator that is already common. Add the numerators and place that over the denominator that is already common. So 4 plus 2 divided by 5, or 4 plus 2 over 5. 4 plus 2 is 6. The result is 6 over 5, and that is represented by option D. So the correct answer is option D. I'm always delighted to see a problem that tests the principles that we should have learned in primary school. Even though the denominator may have been a little bit more sophisticated. Those are some of the concepts that we usually take for granted that can come back and haunt us. I have always known that little things mean a lot, but it is more apparent when I saw a mathematics paper organized by a lecturer and its presentation demonstrated that he missed out on some basic principles in primary school. So let us not take for granted the most basic and negligible principles. I say negligible because we generally neglect them because we say they are simple mathematics. There is no way not knowing these or not being aware of these or not applying these can be hurtful in the long run. That is a big mistake. Ensure that every single thing that you will learn, especially at the earliest level, are maintained, applied, and demonstrated even at the highest level. I think that a little more sophistry could have been added to the numerator, but a problem does not need to be impossible in order to make its point. It is always good to see that some of the most basic principles in the manipulation of fraction are being tested. I am now seeing at the secondary level that students do not remember how to add and multiply fractions. Let us take a look at some of the most common cases that I see. We have 2 multiplied by 3/5. And what do we know? 2 is a whole number being multiplied by a fraction. When multiplying a fraction by a whole number, the numerator and the denominator of the fraction are multiplied by the whole number. That is the mistake that students make. So they say, take these 2, multiply right here. Take it and we multiply down here also. Then they say that the result is 6 over 10. Wrong. First of all, when the numerator and denominator of a fraction are multiplied by the same number, only the appearance of the fraction changes. Its value does not change. So if you multiply something by a particular number and the value is the same, unless that number is 1, then your answer is wrong. If you are multiplying 2 times 3/5, the answer is equal to the same thing as 3/5 written in a different form, then you are wrong. Multiplying by 2 will cause the value of a number to double, to increase. Therefore, something is wrong when we multiply both numerator and the denominator by that 2 that we know does not change the value of the fraction. What do we do? Secondly, do not forget that whole numbers are really fractions whose denominators are equal to 1. You need to remember that. So the 2 is a fraction actually with its denominator equal to 1. Multiply the numerators and multiply the denominators. 2, 3, 6. 1 multiplied by 5 is 5. That's what we do. 6 over 5. Multiplying a fraction by a whole number is equivalent to multiplying the numerator alone by the whole number, because the denominator is 1 and 1 multiplied by any number is that same number. Therefore, it appears as if only the numerator is multiplied by anything at all. It will be very alarming if at this stage students are still adding the numerators, then add the denominators when adding fractions. With the way that students are horrified by fractions nowadays, we may see even worse problems in the future. 2 over 7 plus 3 over 7. What do we have? 5 over 14. That is a disaster. We may liken the situation to a cake that is divided into 7 slices. One person takes 2 slices out of 7, 2 sevenths. And the other person takes 3 slices out of 7, 3 sevenths. The total number of slices taken is 5 slices. However, the total number of slices of the cake is still 7. Surely we do not expect that the total number of slices will increase to 14 because 2 persons are involved. What then? 21 slices will miraculously appear because a third person takes another slice? That is absurd. We do not imagine that such a case will happen. Therefore, since the number of persons that are sharking after the cake is 2, that does not mean that the number of slices will double. The number of slices will remain the same, and that is why when we are adding numbers that have the same denominator, the denominator will be the same. The mistake is more common when the denominators are not equal. However, on such an occasion, a common denominator will have to be found. The common denominator is usually the lowest common multiple of the denominators. This may turn out to be the largest of all of the denominators present, but not always. Continue to watch the videos in Richard James Mathematics Resources. Quite a few problems that we solve required the addition or subtraction of fractions in which the denominators are different. If we continue to watch the videos, then we will be reminded, because I'm sure that you were taught this in primary school. So I'm saying we will be reminded of how to add fractions when the denominators are different. When 7 is added to 3 times a certain number, n, the result is 22. The statement may be represented by the equation. Let us determine the equation. 7 is added to, that is what we are highlighting on this occasion. 7 is added to something. Let us leave a slot for whatever 7 is added to and demonstrate by using the addition sign that we are actually adding 7. So 7 is added to, therefore something plus 7. So what do we put? Something plus 7. 3 times a certain number n, that is what 7 is added to. What is 7 added to? It is added to 3 times n. 3 times n is equal to 3 multiplied by n, which is equal to 3n. Let us place 3n in the slot, that is that slot. So 7 is added to 3 times n, that is what we have there. The result is 22. The result is what the entire statement is equal to, 22. The correct answer is option A. Applied problems, or what we call worded problems, most times drive the fear of hell into students. The problem may be attacked by separating it into statements or substatements. Each statement may be converted to the form required. As we can see in the option, we may use the options as a guide, or we may just exercise some familiarity with such a situation and become natural at converting worded statements or applied statements to algebraic statements. Each statement may be converted to the form required. When the results are combined, the correct answer will be the result. This is making use of a problem-solving method called divide and conquer, and that is what we have just applied. Then the divide and conquer approach may also have its counterpart known as building block approach, but we will not take a look at it right here. Take a look at the booklet known as Steps to Success in Mathematics, and you will see those two problem-solving methods and other problem-solving methods. While reasoning out the problem, it is possible that some candidate may have 7 preceding 3n. So they may put the 7 before the 3n. The answer would still be correct because addition is commutative. That is, the order in which we add numbers or expressions do not affect the result. (2x plus 3 is greater than 9. The range of x is, we need to determine the range of x. The inequality may be solved by using the same principles that we use in solving an equation, which are the same principles that we learn in transposition of formulae. (2x plus 3 is greater than 9. In eliminating positive 3, we subtract 3 from both sides. The result will be that 3 is eliminated from the left hand side, and on the right hand side we have 9 minus 3 is equal to 6. 6 on the right hand side, and on the left hand side we have eliminated positive 3, so we have 2x alone. 2x means 2 multiplied by x. In eliminating the 2, we divide both sides by 2. The result will be that 2 is eliminated from the left hand side, and on the right hand side we have 6 divided by 2 is equal to 3. X is greater than or equal to 3. The correct answer is option A. There we have option A. The steps that may be taken in solving an inequality are similar to those that may be taken in solving an equation, with a few exceptions that we will take a look at on the next slide. This is our first one. In order to find x, it will be necessary to divide both sides of the inequality by a -2. When dividing an inequality throughout by a negative quantity, the inequality sign will be changed to its reverse. Divide by -2, we have -2 eliminated from the left hand side, and on the right hand side 14 divided by -2 is -7. The inequality sign will have to change, so we have x is less than or equal to -7, whereas we had -2x is greater than or equal to 14. Quite often, the steps that students use in solving an inequality will cause the previously unknown to end up on the right hand side. This may be caused by attempting to solve the problem in the most convenient way. So sometimes by solving the problem in the most convenient way, we end up with x on the right hand side. Appropriately, it should be placed on the left hand side. So we are about to put that on the left hand side. When writing the x on the left hand side, changing the inequality around, that is what we call it, the inequality sign needs to be changed to the opposite one. So x is greater than 21. So 21 is less than x, so x is greater than 21. That makes a lot of sense. But if we put that into everyday language, it is clearer. This is similar to saying that if you are older than your sister, then your sister is younger than you are. That's another one. This inequality is analogous to the equation in which two fractions are equal. Solving such an equation, we use the principle that if two fractions are equal, if we invert them, then they are still equal. In the case of the inequality, when taking such a step, which is inverting both fractions, the inequality sign has to be changed to the opposite one. So invert both fractions and we change the inequality sign to the opposite one. And we may finish up by solving the equation. Although solving the equation is not a part of the deal, but to demonstrate occasions that we have differences in solving inequalities and equations, we will continue to solve the inequality. Multiply both sides by 10 will eliminate the 10 from the left hand side, and on the right hand side we will have 3 being multiplied by 10, like so. Do not forget that when a fraction is multiplied by a whole number, it is as if the numerator alone is multiplied by the whole number. The fraction may be reduced by a common factor of 5. 5 into 5 is 1. 5 into 10 is 2. We have x is less than or equal to 6. 3 multiplied by 2 is equal to 6, and any number divided by 1 is that same number. So we say 3 2's 6, then 6 divided by 1 is 6. We have x is less than or equal to 6. Finally, which of the following represents the statement the difference of two square numbers is positive? Difference of two squares. Any candidate that is properly prepared for the CXC CSEC examination knows the difference of two squares in any form or guise. He will therefore have no problem identifying option A as the correct answer, seeing that we have a difference of two squares. And as a matter of fact, it is the only case in which we have a difference of two squares. Option A is correct. The one who is not familiar with the difference of two squares is down but not out. Difference of two squares. We may make use of the two operative words in the statement of the problem. The difference between two numbers may be found by subtraction. So we are making use of the two operative terms that we have highlighted there. Difference and square. We may make use of the two operative words. Difference and square. The difference between two numbers may be found by subtraction. This does not separate the options because all of them contain the subtraction sign. So, difference, if we are depending on that, we are salt, or in proper English, we are salty, because we are saying difference and we are using that term, but all of these are differences in one way or the other, so we cannot use that. The difference is between the two squares that we may be able to use. That the difference is between the two squares. The only option that shows two squares is A. Option C contains only a single square and cannot be correct. The other options contain no square. So we have no square in the other options. Option C contains only a single square. We need, according to what we have here, two squares. I think I should have highlighted two rather than difference. I'll do that on another occasion. So we are saying that the statement says two squares, and option A is the only one that contains two squares. C has a single square and cannot be correct. The other options contain no square. Option C contains the square of a difference, while the statement of the problem requires the difference of squares. Any number greater than 0 has a positive value. Get accustomed to stating the fact that a number is positive by using greater than 0. I would prefer if some of the options, had a little bit more variety, instead of having all of them suggesting greater than 0. We have some less than 0, probably another one greater than or equal to 0. Kind of mix it up a little bit. But a problem does not need to be impossible in order to make a point. Ciao!